unit. This is unit 3, so whatever we do for unit 3 will be behind the third divider in your notebook. Unit 3 is called chemical bonds and reactions. We're going to be looking at the periodic table, and in the last unit we looked at the different elements, the charges they had, how reactive they were, and now we're going to put that into practice, and we're going to see what happens when these elements interact with each other, which elements want to interact with each other, and which elements don't want to react at all. So the first thing I want you to do is, if you have not already, please watch the intro video that I posted on Google Classroom. Next, you're going to have this packet in front of you. We're going to move at a slow pace. Each day we'll be doing some along and along. Today we're going to be doing notes on ionic and covalent bonds and practicing what those ionic and covalent bonds are. So at the bottom of each page you'll see a page number. We are going to turn to page 3. Now, if you have two different colors, get those out. If you don't have two different colors, that is totally fine. Just use your pencil. So we are going to be talking about two different types of bonds, ionic and covalent. And we know that ions are elements that have either lost electrons, like your positively charged metals, or gained electrons, like your nonmetals. So when we form an ionic bond, we will be transferring electrons. Our metals will form an ion by losing the electrons and giving it to our nonmetals. That's an ionic bond. And a covalent bond will be nonmetals that share electrons with each other. So we'll talk about that in a minute. Whenever an element combines with another element, it's going to hold the element together, and it does that. It only bonds because it wants to be stable. So in the middle, in a neutral color, so if you chose two colors, this one's not going to be one of those two. So with your pencil, in the middle, both types of bonds hold atoms together. And these bonds occur when elements want to become stable. Now, what you're going to see is it's not just the element, it's different atoms of those elements. So if you need to pause this and write that down, please do. Okay, so what I want to look at now is what each type of bond does. So here's where I'm going to choose a color. I'm going to choose one color for my ionic bonds. Ionic bonds form between metals and nonmetals. There will always be a metal in an ionic bond. So the word ion means it has lost or gained electrons, and our nonmetals are going to lose electrons and give them, our metals are going to lose electrons and give them to our nonmetals who want to gain electrons. Now, metals and nonmetals have opposite properties, and they don't have very much in common. And just like when you don't have something in common with someone else, you usually don't have much of a sharing relationship with them. If they need something, you may give it to them and move on. So these want to lose electrons, our metals do. Our nonmetals want to gain them. They want to do opposite things. So in an ionic bond, our metals will lose their electrons to a nonmetal. So on the left side for ionic compounds, we are going to write that they transfer electrons. In an ionic bond, the electrons are transferred. They are not shared. A metal gives it to a nonmetal. So since a metal is involved, all ionic compounds will have a metal in them, which means that compound is going to have properties of metals. So one of the properties of a metal is that it is a good conductor. So ionic bonds will be good conductors. Think of salt. Salt is sodium, which is a metal, and chlorine. We know sodium is a good conductor. So they're formed by metals who have a positive charge and nonmetals who have a negative charge. So opposite charges attract to form the bond. All right, now what happens is our metal loses one or more, if it's in group 2, it'll lose 2 electrons to form the ionic bond. Okay, now if we look at the one that's losing the electron, the metal is going to form a positive ion. So a metal will equal the cation, and the nonmetal will be the anion. Okay, so these ionic bonds, since they're just transferring and not sharing, they're going to form and break pretty quickly, meaning they'll dissolve really well. If they can dissolve, we call them soluble. So I'm going to put most soluble bond. That means it can dissolve. Now, because these have metals in them, with an exception of something with mercury, it's going to be a solid at room temperature. We know that solids have a definite shape, so these bonds will have a definite shape. And they will have, because they have metals in them, high, and I'm going to put an arrow up for high, melting and boiling point. All right, so an example of a metal bonding with a nonmetal, we know group 1 wants to lose 1 valence electron, and group 17 wants to gain 1 valence electron. So I'm going to put one of each. Lithium and fluorine. They bond together in a 1-to-1 ratio, since one wants to lose 1 electron and one wants to gain, to form lithium fluoride. All right, now our covalent bonds are going to be a little different. We have seen that metals will give their electrons to the nonmetals because nonmetals want to take them, metals want to give them. It's a quick exchange, and that is how they do that. But nonmetals always want electrons. So if you want something and someone else wants something and you can't find anybody to give it to you, what you can do is use what you both have and share your resources. So nonmetals can bond with other nonmetals to share electrons. For example, oxygen needs 2, fluorine needs 1. They can share the electrons they have to fill up their spaces and make them stable. That's going to be called a covalent compound. So when you see only nonmetals, that is a covalent compound. So if you're using colors, choose your other color. Covalent compounds are going to share electrons, not transfer them. They share them. They hold on to them, but they can share them with the people they're next to. So they share electrons. Now, these are all nonmetal. So we're going to put all nonmetals. And then out beside this, we're going to put poor conductor. Okay, now these are the same charges. So what we're going to write is like charges. So they're all negatively charged, nonmetals are. Like charges share electrons to bond. Like charges share electrons to bond. Now, we know that if you look at the periodic table, you're going to see some solid nonmetals. But most of our covalent bonds, when they form, because we do have so many gases and liquids right here, they will be forming liquid or gas substances. So we're going to put liquid or gas at room temperature. Now, we said that the metals could dissolve and separate easily. These are sharing bonds. They're very strong bonds. So if you share something with somebody, you hold each other accountable. So since they're sharing and they're both using each other's resources, they are going to be mostly insoluble. That doesn't mean they can't dissolve, but it means they most likely will not. So, for example, if we're talking about sugar, sugar does not dissolve very well in water. Now, it will if you heat it up. But right here, we talk about nonmetals. Since metals had a high melting and boiling point, nonmetals have a low melting and boiling point. They don't have a definite shape. And our example can be methane, which is carbon and hydrogen, CH4. Now we know hydrogen is a nonmetal because it's a gas, and it's only on that side of the periodic table because it is has one valence electron. However, it will usually bond in covalent bonds. So if you have methane, CH4, that is two nonmetals forming a covalent bond by sharing their electrons. Another covalent bond would be C6H12O6, which is sugar. It's a type of sugar. Carbon, hydrogen, and oxygen are all nonmetals. Now I want you to turn to page 1. This is page 1, and I want you to use the same two colors that you used on your Venn diagram right here. So I'm going to use purple for covalent and blue for ionic, just like I did on the Venn diagram. So if I've got ionic first, my blue, you can use any color. I'm going to choose all the things that went for ionic. So I want you to look at your Venn diagram back and forth and just try to see if you can figure out, what did I put? Where does it go? What are these properties going to be telling me about, ionic or covalent? So for high boiling point, I know that is ionic. So I would shade this in. High boiling point is ionic. So just shade that in. Make sure I know which color it is. MgO, this is a metal, so I know that is ionic. If I see a metal, I automatically know it's ionic. NaBr, that one right there, sodium, a metal, that's going to be ionic. Known as molecular compounds, that is going to be mostly our nonmetals or our covalent compounds. If I'm looking for metals and I look at many are insoluble, that's covalent. Here's a metal right here, so that's ionic. High melting and boiling points are going to be ionic. Potassium is a metal, so that's also ionic. Potassium is a metal, so ionic. Sodium is a metal, so there's another ionic. It's easier to do all of the same ones instead of putting down and picking up your colors every time. That way you can kind of stay true to which one you're doing. Potassium is ionic because it's a metal. This one's ionic because it's a metal. Potassium bromide, also another metal. Let's see at the bottom if we can find any. Many are soluble in water, meaning it dissolves. We know salts and ionic compounds dissolve well in water. Metal bonded to a nonmetal, that will definitely be ionic because when a metal is involved, it is ionic. Sodium at the bottom, another metal, ionic. Okay, so I think we have all the ionics done. So what we'll do is we'll go back with our covalent color and we'll see if that's true. Carbon and hydrogen, both nonmetals, covalent. oxygen, a nonmetal. It's oxygen with 3 oxygens. That's very much covalent. Hydrogen, nonmetal. It's a gas. We know that ionic compounds will be solids. Covalent will be liquids or gases. NH3, that is the chemical formula for ammonia. It's got 2 nonmetals in it. So nonmetals bonded to each other will be covalent. Many are insoluble. Our covalent compounds are sharing electrons, which keeps them in a very tight bond, which means they are not going to dissolve very well in water. So sugar being an example, I see nothing but nonmetals there, carbon, hydrogen, and oxygen. Known as molecular compounds, we can call them molecules. So for example, where you see O3, that is a molecule. The same element, multiple atoms of the same element bonded together. Hydrogen and chlorine, nonmetals, covalent. This compound, carbon, hydrogen, oxygen, hydrogen, covalent, all nonmetals. Nonmetals are not hard to melt or boil, so they have low melting and boiling points. Low melting points. And then phosphorus and chlorine, definitely nonmetals. So we're going to call that covalent. Carbon dioxide right here, 2 nonmetals, carbon and oxygen. So be sure you have colored these in. And H2O, water, definitely going to be covalent. No metals in water. Not pure H2O. Okay, so what I want you to do is I want you to use the Venn diagram that we have right here. And when you use that, I want you to answer these questions right here. So I want you to pause this video, and then I want you to complete this. I want you to look at ionic and covalent and tell me, in ionic, are electrons shared or are they transferred? Look at your Venn diagram. It says ionic bonds transfer electrons. For covalent, are they shared or transferred? Here it says covalent shares electrons. And stick with the same color. So we're going to share electrons. So, what kind of bond do they have? When we're talking about what kind of bond they have, it means what is the bond between? So, it's a bond with a nonmetal, if it's covalent, plus a nonmetal. If it's ionic, we know that they are transferring electrons. And they are bonds between metals and nonmetals. So if you ever see a metal, you are looking at an ionic bond. You have to remember that. If you ever see a metal, it's ionic. Solubility, is it going to dissolve in water? We have high solubility for ionic bonds. It's a metal and a nonmetal. They transfer their electrons. They don't have a long-term relationship. They're just giving what the other one wants. So with high solubility, that means when we hit water, we are going to dissolve. And they make compounds by the attraction of oppositely charged ions. Now, we don't have oppositely charged ions for covalent, so they're sharing their electrons, which is a very tight bond. So they're going to have low solubility. All right, now at room temperature, we know that these are going to be liquids or gas at room temperature. And we know that because there are metals in our ionic bond, they are going to be solids at room temperature. Now for the melting point. Ionic bonds, because they are hard to dissolve, not hard to dissolve, sorry, is hard to melt a metal. They're going to have high melting and high boiling points. Covalent are going to have low melting points, and they're easier to melt and boil. Conductivity. Ionic has metals in it, so we know they are good conductors. Covalent bonds with all nonmetals are poor conductors. Now, what I want you to do is I want you to take what you know from this, and I want you to flip to page 4, and I want you to start answering these questions. This is going to be graded, so if you don't finish, that is okay. We can work on it another day, but just make sure you start looking over these questions, okay?